Hi, today I'd like to talk to you about testing strategies for AngularJS. This is a topic that is really near to my heart because I didn't have a big background in test-driven development or even just the experience with understanding how to test. And about 3 years ago, I got the awesome opportunity to pair with a friend of mine, Justin Searles, for a good 6 months on a project. And he really introduced me to the idea of testing JavaScript and testing web applications and test-driven development. We're not going to cover test-driven development today because I think that that's a topic that's better suited to learning in a pairing environment where you can actually pair with somebody. So what we're going to look at is some strategies that you can use and maybe just elevate the discussion a little bit more than just tools and talk about the ideas and maybe some questions you can ask your team or you can ask the people that you work with to get a conversation about some nuance in understanding how you test. So let's look at the outline. Just a quick note, this is a follow-on to the series on AngularJS screencasts that I've already produced. You don't have to have watched all the other ones, but there will be some context that I'm referencing from the previous videos. Mainly, we're just going to be working with the same sample app. So if you've seen the introduction to AngularJS, end-to-end security, or front-end workflows with AngularJS, any of those would probably give you enough context to move forward. I'm just going to talk a little bit about why testing's hard and how the terminology that's out there for testing strategies and different techniques and tools and things that we use is hard for people that are new to this arena. After that, we're going to look at why strategies are probably a better thing to focus our energies on instead of talking about tools, and this idea of budgeting for reality in tests, which is really the most important thing, I think, when coming up with a testing strategy for your application. We'll look at some the boundaries in an Angular app, and the previous topic on budgeting for reality in tests will inform us about how many of those boundaries we want to cross in our different types of tests. And then as we look at a couple specific examples for Angular, we're going to look at this idea of low-resolution tests for controllers, directives, and services, and high-resolution tests where we're actually going to spin up a browser using Protractor, which we'll talk about a little bit later. The focus of this screencast is definitely not going to be on tools, but there are some tools that we're going to use. So along the way, we'll take a look at Testem, which is a framework-agnostic test runner. Another tool that we're going to look at is Jasmine. You're probably familiar with it, so I'm really not going to spend a lot of time touching on the finer points of setup and things like that. Protractor, which is a new end-to-end test runner for Angular. It's Angular specific and it has a lot of cool features that we'll be going through as we work through a couple end-to-end tests. And then Lineman, which you've seen if you watched the front-end workflows with Grunt and AngularJS video, which is a productivity tool that the guys at Testem, which is where I work, put together for you to be able to build rich client web applications. So let's kick things off by talking about why testing is hard. When I first came into test-driven development and just getting introduced to the idea of testing 3 years ago, there was all this terminology floating around. There was X-unit test patterns, there was test doubles and mocks and spies and all these different words that I didn't really understand. And I think that is intimidating to people that come to testing for the first time. And they really don't understand that the high-level question that we want to talk about isn't, or ask when it's related to testing, isn't whether I should use spying or mocking, or should I mock or should I not mock. Those are sort of more advanced questions. The real question that we want to ask is how much reality does my test need? And my coworker, I mentioned Justin Searles, he has a really good presentation, and I'll put a link in the video description on SpeakerDeck, talking about reality being expensive is a better way of thinking about mock objects. And he goes through sort of this idea of reality in terms of tests and how it's expensive. And so he had this idea that you may have seen something like this testing triangle before, and I've actually replaced the specific names of the types of tests because I don't think it's important when you're first coming to understanding testing. I think it's more important to ask the question, how much reality does my test need? Because if you think about a test that crosses more boundaries, where you're actually spinning up a browser to test your Angular application or whatever application, that's a super high fidelity test. That's really close to reality, right? That's at the top we've got Mario here in real life, where he represents maybe somebody on your team's going and manually testing your application. That's sort of the smallest point of the pyramid. We should probably do some manual verification, but it's super expensive to do that and to automate that. Those tests really verify that we built the right thing because they are as close to reality as we can get. But we should really consider that as part of our testing strategy and budget accordingly. So that's why it's at the top of the pyramid. It's a smaller chunk. We should have some of those tests in our application and in our testing strategy, but they shouldn't make up the bulk. And on the flip side, we've got 8-bit Mario from the original NES era here, and this represents sort of the bulk of what your testing strategy should be made up of, which is low fidelity tests that are cheap to run and automate, that are really good at verifying the behavior of individual components in your system, but not necessarily all the pieces. And so, understanding that we need to ask this question, how much reality does my test need, is important when devising a testing strategy for your team. So with that, let's talk about some boundaries that you might run into in an Angular application, because it's important to understand what all the pieces are in an Angular application. So let's talk about boundaries. So when we think about what happens when a user spins up an Angular application, they're probably going to use their browser. So that's sort of the first level. And then there's a boundary between that and the ng app directive, which if you've watched the intro video and the other videos, I covered what the ng app directory is. So Angular is going to look for that directive in order to bootstrap the app. And then the next boundary, maybe there's a route. You don't have to use a router in Angular, but maybe you've got a router in place. And so there's a route that fires, and then it's going to probably render a template into an ng view that you've got. So there's another boundary. It's got that template. That's a boundary. There's some directives in that template that the Angular compiler and linker has to go through and sort of look at the HTML and instantiate all of the pieces for the template so that the dynamic two-way binding can happen and things like that. So that's another boundary. And then a controller probably gets instantiated. So there's yet another boundary that we're going to have to work with. Inside a controller, we've got a scope, and then there's various services that you might be injecting into that controller. There's another boundary. So for example, HTTP or maybe $resource, things like that. And then behind HTTP and $resource, kind of before any requests get made to our backend, there's actually something called HTTP backend. And this is important because we're going to take a look at, with our testing strategies, at why Angular chose, as a design decision, to include this HTTP backend. If you're familiar with jQuery.ajax, and maybe you've built a backbone application or another low-level app, even just with like vanilla jQuery. One interesting thing is that there's some private methods under the hood, but there's nothing like a concrete abstraction like this HTTP backend. And it's one of the design decisions that makes Angular really nice to test. And so after we get to the HTTP backend, we're probably going to forward off to XHR, so to the native APIs that the browser vendors provide for communicating asynchronously with our backend. And that's sort of the next boundary, is to our web server. We've probably got some sort of ORM, some sort of object relational mapper, and then that's going to generate queries which are going to hit our database. So those are all of the boundaries in our application. So when we talk about how much reality we want in a testing strategy, maybe thinking in terms of lo-fi, a test might cover a couple of these boundaries. So maybe from browser all the way over to directive. Maybe that's you're going to come up with a testing strategy when testing directives, and those are the boundaries that you want to cover. You're probably not going to hit all of the pieces in between here. Maybe you're going to cover the browser. Maybe you're just going to cover the directive directly and a template and a controller. Maybe you want to do that. Maybe you just want to test the controller and the scope for a controller test. So there's all kinds of different things. Maybe for a service, you actually want to use the service directly, a scope to manipulate with the service. Maybe you actually want to test the HTTP backend in relation to those things. So when we talk about boundaries and the amount of reality, these are sort of examples of lo-fi pieces that we might want to test, and we'll take a look at some specific examples. When we talk about hi-fi, we're basically talking about all of the boundaries that we can. So browser all the way through to database, and that amount of reality is really good at verifying that what we built is correct, but it's not really easy to automate. It's not super easy to maintain, especially if you are asserting too much in those types of tests. So that is about as much as I want to say about boundaries. Going forward, we're going to take a look at the app that we built previously, so I'm just going to start that up, and we'll get started with just a quick tour of what's in that application. So I'm going to run Lineman, which is the productivity tool we covered in front-end workflows with Grunt and Angular in the second half of that screencast. And that's just going to spin up a local Express.js server with our app. And if you remember from previous screencasts, or if you don't, there's no requirement to the username and password here. There's just a simple app that's going to redirect to the home page. When I mouse over these images, I get some dynamic behavior happening, and I'm going to log out and things like that. There we go. And I've added a third route in here that we're going to use, which right now is just returning me the data, so some books. And we're going to look at what that route shows on the screen. If I just open up the router, right, I had to change it to list of books. There we go. So fetching from a book service to render some books on the screen. So the list of books, the login page, and the home page. Nothing real crazy. So we're going to look at some testing strategies to see how all of these pieces work. So let's start with the login page. So we've got our app definition here in the Angular module. We've got a route provider set up to listen for the login route, and I've got HTML5 mode enabled, which is why you don't see the hash in the URL. So I can actually click around here and go to login, and the Lineman is actually simulating HTML5 push state for us. So that's one of the cool features in Lineman that you can use when you're developing your apps. Just wanted to point that out in case people were confused. So let's look at what kind of behavior is happening at the controller level. So let's look at that login controller and see that there's not a whole lot. If you remember from the previous screencasts, we built an authentication service that had some various properties about how it interacted with the backend. And there was a login form. I'll just pull this to the side here so that you can see, if I go log out, there we go, you can see that login form with the username and password field. And when the user logs in, we redirect them to the home page. So that's basically the functionality we want to test first. And the testing strategy that we're going to use to test this amount of code is the low fidelity. So not a lot of reality, but that's going to mean that this test is super cheap to run and super cheap to automate. And so we can kind of have them running continuously. So one of the cool things that we have in Lineman is this sort of opinionated directory structure that gets scaffolded for you when you create an app with Lineman, and spec is one of the directories. So if we take a look at our app code, we've got JS, we've got controllers, directives, resources, and services, which should be familiar from the previous screencasts, and we've got our spec folder set up to mirror that. So let's add a new spec for the login page, or the login controller rather. So we'll call it login controller spec.js. And we're going to be using Jasmine. I mentioned that was one of the tools. And Jasmine gives us two keywords to work with our specs for describing them. Describe, so I'm going to describe the login controller. and it just takes a function as its second argument. And then the other cool thing that we can use is it, and it is where we define our behavior. And so the thing that we want to verify about this test, and this is sort of one way I like to operate, is I just start enumerating test cases to describe the behavior that I want when I'm building my system. I'm just going to split my window in half here and put the code under test at the bottom. So I want to describe what successfully logging in looks like. So let's do that. And to do that, one of the first sort of things that comes to mind when you're talking about testing Angular code is, well, how do I actually get at that code under test? And this is relevant because Angular hides away or encapsulates things inside of this idea of Angular.module. And when you're actually poking at the page, if we go back to Chrome DevTools, I can take a look at the state of Angular in the global here. You can take a look, and you can see all of the sort of public functions that are available off of Angular, but there's not really any easy way to get a hold of the actual module or the code. I mean, I can look into the sources tab and I can see all that code, so I can go to controllers and look at the logging controller and see that, but I need to be able to get a hold of this function inside of here so that I can start poking at it. And that's one of the first things that you'll run into when you're writing sort of low fidelity tests that are trying to isolate a specific unit of functionality. And so the first thing that we need to do is we actually need to make that available to our test. And Angular has some built-in helpers that give you the ability to do that. And one of those is a global function. The full reference to it is angular.mock.module. And we'll just call it module for short because it's available as an alias. And the first thing that we want to do is say, hey Angular, we want you to make available the stuff that's inside of that app module for this test. And that gets us access, to this level of code. And so that's one way that we can grab the unit of functionality under test for our small low fidelity test. The next thing we need to do is we need to figure out how we're actually going to grab this specific controller. And Angular's got another couple of things that we can do to grab that. And these are all available in Angular mocks. So let's just open that really quickly because I think it's useful to take a look at this. And there we go. So at the low level, ng mock or Angular mock is basically a set of pieces of the Angular architecture that are faked out so that when you're testing your Angular code, for example, here's that HTTP backend I talked about, that you're not actually going to make XHR requests. We looked at that boundary between HTTP backend and XHR. So when you're running in test mode, Angular swaps out this real HTTP backend with a mock HTTP backend. And basically, all that means is it's reducing the amount of reality in our test, right? So that it's a lot cheaper and easier to run, and we can verify bits and pieces about this specific unit under test. So in order to grab the module, we use module and we say app. That goes in Angular mocks, and if we look for module, angular.mock.module, we can see right here that there's a couple of things that does for us. It basically sets up, it's available on the window object, so it's globally available. And it sets up a context for our current spec that's running. So it will tear down automatically so that before each spec, we're setting the context of the code that we want to test, which is our app module. But then after each spec, it'll tear down and remove that, so we don't have any test pollution between test runs. So let's grab the context of our actual controller. And so to do that, we need to instantiate it. And the next keyword that we're going to interact with is something called inject. And this is, if you've watched the other screencasts, this is the way that you inject dependencies using Angular's dependency injection. And we're going to say we want to inject a function, and we want to inject the controller in this argument. We're also going to need a root scope because our controller, as you can see, one of the dependencies is a scope. And then the rest of the things I'm going to enumerate are just the other pieces that we need to create a version of this controller in our test. So let's do that. So when we say inject, when we say module, that sets up the context for our module under test. Just for this test, it'll be torn down after so that there's no test pollution. And we can say inject and pass it a function, and all of these specific dependencies are available because the ones with prefix with $signs are just part of Angular's core framework, and this authentication service is available on our app module. So that's how we can grab the dependencies, but how do we instantiate it, the controller? That's where this controller comes into play. So we want to say, we want to set up a controller, we want to set up the login controller, and this, you can see this string matches the name that I've defined the controller as up here. And then we're going to want to pass it some properties when we instantiate that controller. We want to pass the scope, and we want to say root scope dot new. That gives us a new instance of the scope that is set up automatically for you by Angular. We want to pass that location in, like so, and our authentication service. And so now if we spin up Lineman's test runner, which is called Testem, which you can do if you go to the command line and type lineman spec. So we've got lineman running here so that it pulls in file changes. Looks like I've got a syntax error in my spec. So let's just run JS hint on this thing. Looks like I'm missing a line 13. Oh, missing one of them. Let's run it again. There we go. Now is it happy? Good. So no tests were run, but at least I don't have any syntax errors. So let's get back to describing successfully logging in. Again, this is our unit of functionality with the controller, so let's take a look exactly what happens. There's this method called login on the scope, and when login gets called from somewhere in the DOM, there's an ng click handler in our login page. The authentication service's login method is going to get called. It's going to pass the value of scope.credentials, which is an ng model that's bound. And then when that's finished, it returns a promise, because under the hood, the authentication service is using HTTP, which returns a promise. So with those credentials, we're going to log in. And then when we have successfully logged in, we'll call this onSuccess callback, which results in the user getting redirected to the home page. So that's just the behavior we want to describe. So let's do that. So successfully logging in, it should redirect you to home. So again, with this idea of boundaries in mind and the amount of reality that we have in our test, I don't actually want to spin up the DOM and insert all of the pieces necessary to do this. I just want to sort of simulate what the boundaries are from the controller layer to our authentication service, and assert that the location .path method was successfully called after the authentication service successfully logged in. So that's the testing strategy, or the idea that we're going to use here. So the first thing that we're going to do is we need, in our before each, to make some things available on the scope that this Jasmine test runs in. And the first thing that we're going to interact with is the location. So we can just assign it to this. And now we have, doing this is going to make it available inside of our it block down on line 19 there. We're also going to want to grab the HTTP backend. And we're going to need to inject that in this injector here. And we're going to need the scope, because we're going to want to make some assertions about the scope. So let's do this. Let's move that line up. And then we can just say this.scope. And those are the pieces that we need to start anyway. So because Angular provided this HTTP backend, if we just go back and look at our boundaries, when running under test, this piece is going to be fake because we included Angular mocks in our test helper setup, which I mentioned before is a really nice design decision. It turns out that because of that, we can actually make assertions against the backend and sort of train it to respond to our requests as if it was a real backend in our test. And this is pretty cool. It allows us to isolate with less reality, but not have to have our tests be super complicated in order to do that. So let's look at how we're gonna assert what's happening. So let's investigate. That authentication service.login method is really what's going to get called when we call our scope.login, and that's going to call HTTP post with /login and any credentials that get sent to it. And so when we talk about testing strategies, one of the first things I learned when I learned testing was this idea of arrange, act, and assert for how you want to structure your tests. So let's break our into those three things. Let's do arrange first. And so the first step that we want to do in our arrange is we want to grab that backend and we want to say you're going to expect a post. These are just helpers that are built in. You can check out the documentation. And the value that you're going to expect is you're going to expect a post to /login, and then we're going to say you want to grab the credentials. Those credentials are going to be on there because right here we've instantiated our login controller. And so the scope is really the piece that we want to make assertions against. You can see here on line 2, when that login controller gets instantiated, there's a username and a password property that gets set here. So those are what we're going to assert, that the HTTP backend got an expect post passed to it. And then we're going to say, and when that happens, we want to respond with a 200. Because at this point, we don't really care what the response is. We're just testing that the plumbing in our login controller works as advertised. So that's our arrange step. What's next is our act step in that arrange, act, assert. And to get this to work, we're going to need to interact with our controller somehow. And the only publicly available function on our controller is this login method, because that's what's bound in the login template, which I can just open here. So we can see that when the ng submit directive is detected, it's going to bind the login function to the submit event, and that login function exists on the scope in that controller. And so that's our entry point for the test in our act step. So we're going to say this.scope.login in order to act. And then once that's in place, we want to do some assertions. The second piece of act that we need to do isn't actually related to our code under test, but it's related to the HTTP backend. So because the nature of HTTP backend is that it's asynchronous, and all of the requests that go through $HTTP or $resource when you're working with Angular are asynchronous. They return promises, which is really nice, so you can compose them and treat them, your code, as if it was synchronous. But the HTTP backend has sort of mocked out the idea of that asynchronicity. And there's an internal cache of deferred objects, and if you're familiar with the queue library, which is the Angular implementation of another popular promise library, you'll know that one of the properties of a deferred is the ability to resolve. And so in order to properly get our HTTP backend to respond to the request that login is going to send through the authentication service, we need to call flush. So those are the two things that you will work with. And we'll take a look a little bit later about or at some other strategies that you can work with HTTP backend. So we've arranged our server to respond or to expect a post and then respond with a 200. We've acted by calling scope.login, which is going to trigger that request. And then we're saying, okay, I need to respond with the server. And then now we want to verify some of the behavior. So let's use Jasmine's expect. And we're going to say we want to expect some redirect function to have been called with home. So if we do that, we can see that we got a failure here. Expected a spy, but got undefined in Testem. Testem is awesome because I can fire up Firefox, for example, and I can connect to localhost 7357, and now I've got two browsers that my tests are going to run in. I can hit enter and they'll rerun again, and whenever my files change, alignment is set up so that it'll automatically do that. So one of the nice ways I like to work in my test workflow is to sort of put this window near the bottom, and then grab my code window, and I'm doing this at a low resolution so you can't see all of this. But now if I say foo, for example, and I hit save, you'll notice that those browsers all got refreshed, and I can see the results in my terminal. So I don't have to really switch to the browsers, but if I want to debug, I can. So that's Testem, and that's as much as I'm going to show you about Testem. If you use lineman, like I said, you get that lineman spec command. So while your app is running, it'll detect file changes, and it'll work for you. There, it reconnected to those browsers that were already open. The thing that we want to verify is that our redirect to login got called, or to authenticate got called, and we get redirected to the home. So let's make this location object, and let's say this.redirect equals spy on location path. And what that's going to do is, if we look at the test now, hey, we're green. So let's understand exactly what this is doing. Basically, what we're doing is when we inject location, we get a copy of the location object from Angular, which has one of the methods on it is path. And if we go through our login controller, we can see that when that authentication service logged in with the credentials and was successful, it's going to call this on login success callback, which calls location.path home. And so in our test, that spy method is basically saying swap out the behavior of location.path, or replace the function with a fake function. And the spy has some properties that we can assert about it in order to verify the behavior of this code under test. So we can say, given that we've arranged our server to expect this, we've called that login method, we've flushed out the server to get the response from the fake server, and then we can expect that redirect, which is just a local variable, that's just what I'm calling location path. We could call this location path if you wanted to have been called with home. So this is a low budget test in terms of reality. There's not a lot of reality here, but what it does by us is we've now asserted that our code in here works as we expect it to, just within this one module, this login controller. And that's pretty powerful, and we can run those tests, in browsers. We could spin up Phantom.js if we didn't run them in the browser, and they'll run pretty fast. So that is sort of on the low reality end of the spectrum. And you may have heard of something called the Angular Scenario Runner for sort of this idea of end-to-end tests. And so what I'm going to show you is something called Protractor. And Protractor is a project that a Googler named Julie Ralph has been working on. And it's a really, really cool, different approach to testing Angular applications. And it sits on top of something called WebDriver, which is, if you've heard of Selenium, it's an interface for interacting with Selenium. And the specifics aren't super important. I basically just want to show you how you can set up Protractor and some of the features that it gives you. So we tested our controller. Let's actually verify, going back to this idea of boundaries, we've got our lo-fi, we verified, we got a piece of our app, we got a specific controller over through to scope, we covered a service, so we've got maybe that much reality, that many boundaries being tested. We did kind of cover over into HTTP backend, so that sort of slice through what I've got highlighted there in terms of text is what that login spec covered. So now we want to build a test that basically covers all of this except the database part. But we do want to hit the web server that's running in our little lineman app so that we can verify that logging in works as expected. So let's do that. So the way that you add Protractor is you're going to want to add it to your package JSON. So I've installed it with npm here. here's Protractor 061 at the time of recording of this screencast. And so to do that, I'm just going to quit out of Testem. I did npm install Protractor save, and I'm not going to do it now, but that's what pulled it into my package JSON. And that'll pull in Protractor, and you can see it inside of node modules here. And so the config file that Protractor gives you looks like this. You just export a config object, and there's a couple of properties that you're going to need to set up. One is the Selenium server standalone, which you can do with Homebrew, and I'll have instructions in the README on how to install that, but it's basically as simple as brew install Selenium standalone. You'll also need Chrome driver. Selenium by default, I used to drive Firefox as its browser, and Chrome driver is available so that you can fire up Chrome with it. And so thinking in terms of the amount of reality that we want, this test is actually going to fire up a browser and actually going to hit our app and actually sort of poke at the different things in order to verify some behavior. So we can either tell Protractor where our Selenium server standalone file is, which port we want it to run on, and where Chrome driver is. And if we do that, it'll actually spin itself up on its own. So let's do that first. I've got these paths here set up, and it's going to spin up Chrome. It's going to go to localhost 8000, which happens to map to the port that my lineman server is running on. If I reboot up lineman, you'll see. Yep, 8000. So we want the actual, web server for our application to be up and running when we're going to start up this other test. And we're going to point it to that base URL, and we're going to point it to which specs. So the first one we're going to write is called login spec. So let's do that. Let's take a look at this spec E2E folder that I've got here. So the first spec folder, I've got that login controller spec, and let's look at spec E2E and make another one here called login spec.js. The difference between our spec that we just wrote here and the spec that we're going to write now is that this spec runs in the context of the browser, and the E2E spec that we're going to use Protractor for is going to run in the context of Node.js. And so we're going to see how that works. So the first thing that we need to do is we need to grab Protractor. Since we have it installed, it's available to nodes require facility. So we can just say, I'm going to grab Protractor. The second thing that we need to do is we need to grab Protractor's wrapper around some of Jasmine's constructs. And I'm not going to dig into this too much, but basically the Protractor consists of a couple of helpers that wrap the basic Jasmine constructs. So this test is going to look a lot very similar to what we already had in the previous test. We're going to describe the app at a top level, because this test is going to spin up the browser. We're going to assign a local variable called ptor, which stands for Protractor, and the names of these aren't super important. So let's describe visiting the login page, where we actually spin up the browser and visit that page. First thing we do is we interact with that using ptor.get/. So that's going to tell the browser to go to the root of our application. So once we've done that, actually I wanted this in a before each. Let's describe when the user logs in. Let's take a look at this behavior. So I can log in as whoever. So when I log in, I get there and I have this default message that's on the home page. So I'm gonna write my Protractor test so that it actually does that. So we're gonna go there. When the user logs in, it should redirect me to the home page, and I should see a message. And that is, a lot more reality and a lot more boundaries that we're covering in this Protractor test. Protractor has a library available in an interface. That's what this. Oh, I know what I'm missing. I need to actually assign the value of that thing. So this was a describe. I need to say ptor dot equals protractor.getInstance, and that's going to get me the instance of the Selenium WebDriver and the Protractor wrapper around a lot of the WebDriver hooks. And this is going to be wrapped. Tab that in. And now I can put my before each with my ptour and git slash. So when the user logs in, it should redirect me to the home page, and I should see a message. And so one of the things you're going to want to do is interact with the pieces of the UI on the page. So in this case, I want to actually be able to tell the browser to fill in the username, fill in the password, and hit that login button. So let's see how we would do that. And that works with a couple of ptour functions. First one, we can tell it to find an element, and we have a strategy that we can use to find that element with the Protractor library. So we want to find it by input, and if we open up that login, let's move that over and open up our login HTML. Let's split it that way. We can see that there's a couple of pieces of information here, and if you've used end-to-end test tools before, you might have used a DOM selector, so like an ID on this input to select to be able to manipulate the browser. The cool thing about Protractor is it's got these strategies for selecting elements that are aware of Angular bindings. So when we say protractor.byInput, what that's actually doing is looking for an ng model attribute. So we can actually just grab credentials.username, which is pretty cool. We can say send keys to send a specific set of values there. Let's do Ralph. Let's do the same thing for the password. And these values don't matter. The next thing we want to do, so if we have those values filled in, we want to submit the form. So let's find that element. And using a different strategy, we're going to say I want to find an element by ID. So sort of using just the DOM selector, login, and I'm going to call click on that thing. And that should basically get me as far as to the next part of the page. So let's run that and see what happens. So the way that you do that is node modules, protractor, bin protractor, and then you pass it your config. So we want config spec e2e. Just to remind you that that config looks like this. And because I uncommented these lines, Protractor is just automatically going to fire up. So let's see how that works. So it's going to start up Selenium standalone, which takes a little bit of time. There we go. There, it fired up Chrome. It's filling in the information. And I don't actually have any assertions, but it didn't fail. And you saw that it pulled in the, or it filled in the form field. So that's pretty cool. And you know, again, we've got these strategies that we can select elements, we can select them with some Angular intelligence, and I'm not going to cover all of the Protractor things, but you should definitely investigate it because Protractor is at some point going to replace the Parma scenario runner, the Angular scenario runner. If you check out the Protractor issues on GitHub, you'll see that. So let's make an assertion about this thing because we actually want to be able to verify that was working. We want to find that message element. So if we're on the login page, we go here, we want to find this message element and verify that that value is set. And that's going to cover a whole bunch of boundaries. It's going to cover the home controller, which if you remember from the previous screencasts, we had the scope message. So that's going to cover, you know, did we get redirected? Did we get the right template rendered? Did that controller get instantiated? Did the value on the scope get set, the message in this case? And we can assert all of that and have a high level of fidelity for this test. So let's grab a different strategy for grabbing this information. So I said before, Protractors is aware of how Angular operates. So let's take a look at that home HTML template. And we can see that, the place that message lives that we want to assert against is right here in this div with a class of alert box, and so we can grab that. So we could grab this by CSS class, but then we get an array of elements and we have to index in and figure out which one it is. We could add an ID, but one of the problems I've seen with sort of high fidelity tests is designers will come in and they really want these things to be flexible, to not be able to, or to be bound to a specific class or an ID. And if you've got developers using class attributes and ID attributes as hooks for your high fidelity test runner, it can definitely make those tests more brittle. Protractor solves that problem by giving us a strategy to select elements that is aware of Angular bindings. So I can say by binding and actually just pass it this string. So if we go back here and say protractor.byBinding and pass it that, that's another strategy that I can use that isn't coupled to any particular class attribute or ID attribute, and so it should be much less brittle for designers who are going to come in and modify these templates and change things, which is really cool. That's an awesome thing and should make your designers very happy on your team. So after we grab that, we want to grab the text, and then the other cool thing that Protractor does is it wraps a bunch of the functionality that would normally make you have to write async tests in Jasmine using the runs and waits. And it wraps those in promises. So we get a venable that we can pass. So we can pass it a callback, which is going to contain that text. And then now we can make our assertion. So let's fail the test first. Let's expect that text equals foobar. And we'll rerun our protractor test. And after this run, I'll show you one of the techniques that you can use to, if you're going to be running these tests frequently, to avoid having to wait for this spin up time. So there we go. We got a failure, and it gives you a nice stack trace and a message here. So my Angular app visiting the login page when the user logs in should redirect me to the home page, and I should see a message. That's my all of those strings of the describes and its sort of stuck together in the output from Protractor, and we get a message that says, expected. Mousing over these images to see a directive at work equals foobar. So that, obviously that's working. Let's grab that text and let's make it pass. And let's use a different strategy for starting up the Selenium standalone server. So you can actually do this. You can say java-jar if you've got Java on your system. Point it to Selenium server standalone, that jar file, which port you want to run it on. Again, these are all things that are in that config file. There's 4444. There's the path to Chrome driver and a flag that says you're going to use Chrome driver. And if we set that up, it's going to launch a Selenium standalone server that's just going to sit there and wait. And so now, once that's done, I can go back here and comment these out. And I can just say, hey, Protractor, I've already got Selenium running, so just use this, this hub, this WebDriver hub. And so now, if we go here and say, run that, it's already using the hub, so they start up a lot faster, and you can see that we get our super high fidelity tests running, and we can just leave that running. And high fidelity tests, again, I said, are typically pretty expensive to run. This test asserts quite a bit about our system in terms of reality. It's crossing a bunch of boundaries, like I had selected here. Not 100% reality, but it's still pretty cheap, and Protractor makes it very easy. I mentioned before, it's specific to Angular, but it makes it very easy to sort of manipulate the state of our app just by using these different strategies for selecting things that are typically sort of cumbersome if you're just used to writing high fidelity specs with Selenium. We have one directive in this app which is responsible for showing this message when we hover over these. Let's test that really quick. So let's add another test here. And instead of JavaScript, I'm going to do this one in CoffeeScript. And some of you might not be fans of CoffeeScript, and that's okay. But I think it provides some advantages in terms of terseness. And we've got a couple helpers that I'll showcase as well. Spec.coffee. So let's open that up. One of the helpers that Justin Searles wrote is called Jasmine Given. which we can take a look at. If you've used RSpec and tested in Ruby before, one of the really nice things about it is the ability to split out our range, act, and assert into given, when, then. So, here's a really good example. Given a number 24, when I times that number by 2, I add 1 to that number, then I expect that number to be 50. And the nice thing about CoffeeScript is it just really reduces the amount of noise that we have in our spec. So, if we take a look at this login controller spec, we can see that there's quite a bit of noise in there. When we use CoffeeScript, we can get rid of that. And we've got some Sublime text helpers that you can actually use. So I can hit des, and it'll give me a describe here. I can hit tab, and it'll give me the block already defined. So let's write a test for our directive. Shows message when hovered. Let's open up the implementation of that. If you're familiar with this from the previous videos, you know that this is an attribute directive. If we take a look at the home page, you can see that that attribute directive lives on those images, shows message when hovered, and there's a message attribute, and it swaps out the original message up here with the value here on mouse enter, and restores the original message on mouse leave. So, how do we get a handle to this? What kind of testing strategy do we want to use? We don't really want to have a lot of fidelity here. I definitely don't want to have to attach anything to the DOM, and Angular makes that desire really easy in testing this stuff. So let's do that. So instead of a before each given, just maps to before each. So we can say given the module of app and given inject. We're going to need a scope for this thing. Let's just pop that guy. Shows message when hovered, so we can see the code under test here. So we're going to inject that root scope. We're going to need that because that's where the message is going to live. And we're going to need something called compile. So for our controller test, we injected controller. For directives, there's two phases. There's a compile and a link phase. And we're not going to do link because link actually will bind that that directive to a piece of DOM, and we don't need to do that in order to test. So let's set up our initial message. Ralph is here, and at is the CoffeeScript shorthand for. I can display the JavaScript. This, so you can see there's the JavaScript. So given we're going to inject this stuff. The next thing I need is the actual HTML that sort of describes how my directive is going to be used. So let's create a div and have shows message when hovered. And we'll include a message. And the default value using CoffeeScript string interpolation is that directive message. And I'm just going to make this big again so you can see the whole thing. And we're going to need a scope. Again, we can say root scope $new to get us an instance of a scope. We want to set the value of the message equals something called original message. And things are looking grim. And I'll display the JavaScript for you people. So this.scope.message equals this.original message equals things are looking grim. That's just a bit of shorthand to assign the same value to two places, scope.message and the variable called original message. And let's use that compile that we injected. So we want to call compile, and compile takes some HTML and then a scope, which returns a function that takes the scope. And so that's all we need in order to be able to test, to make assertions against this thing. So let's describe the stuff that we want to assert here. There we go. So when a user mouses over the element, and now we can use when. We can interact with that by saying trigger handler, mouse enter. And our arrange act assert steps basically become the descriptors. You can have a then with just a function argument, which is what these single arrows are in CoffeeScript. So when describing when a user mouses over the element, when we trigger that handler, then we can say the message on the scope is set to the message attribute of the element. And now I can just say scope.message equals at directive message, because that is the value that we stuck on this thing here. So let's spin up Testem again, because I killed it when I ran my Protractor stuff. There we go, 2 tests are complete. You can see the Jasmine runner there and the nicely formatted messages. So the directive shows message when hovered. When a user mouses over the element, this message is set. Let's make it fail so we can see what happens there. And Jasmine given formulates the error messages that come back to Jasmine with a little bit of sugar. And so we can see that I didn't have to use expect because everything in CoffeeScript is an expression. So if I actually evaluate this and show you what the JavaScript looks like, there we go. And let's show them side by side. Oh, we got like 8 lines versus 4 lines, so it's usually a factor of 2 reduction. But you can see that the last thing that this function does is return this.scope.message triple equals Ralph, which it obviously doesn't. And I could also use expect, which is built into Jasmine. This is an assertion mechanism to be Ralph. If we go to the Testem runner, now we can see this is sort of what you expect from vanilla Jasmine. Expect Ralph was here to be Ralph. And if I put this guy back at directive message, there, now we're good. So those are just some options that you can have when you're writing your specs. Jasmine given and CoffeeScript are a nice sort of alternative. Oops, in CoffeeScript you don't actually have to write triple equals. You can just write double equals. Let's write another spec. So when a user's mouse leaves the element, and we've already got our given sort of as the before each up here with our inject to set up the state of the element. It's going to run that before each describe block. So given all of that stuff, let's trigger mouse leave, then the message is reset to the original message. And again, because everything in CoffeeScript is an expression, we can just say original message, which we assigned up here. There we go. Let's look at the directive and make that fail. So instead of attributes.message, let's say food. And you can see that that failed. And you can see the output in the console is a little different than the output here, just the formatting of it. But we can say that then clause returned false. So let's go make that pass again. Attributes.message. There we go. And so you can see the whole time that my tests are, or that my files are changing, I'm integrating against those tests. And so that is sort of the power of tests that have less reality. They can run really fast. Let's just recap kind of some of the advantages to Angular's testing of directives. I didn't actually need to inject anything into the DOM. I can just create this arbitrary HTML string. I can sort of reveal the intent of how this directive is supposed to be used by just placing that attribute on this element. I can grab a scope, set some properties that the directive is going to be using, and then I can call Angular's compile facility with that HTML, and then which returns a function that I can pass a scope to. That's as simple as it is to test directives and controllers, services. There's nothing magic about testing services. If we wanted to test our authentication service, we could do something similar to how we tested login by spying on, let's take a look at the authentication service. We could spy on HTTP post. We could spy on and assert that login was called with credentials, logout was called. or we could use HTTP backend like we did here and train it to respond in a certain way and verify some things in that regard. Let's see if I covered all the bases in what I wanted to talk about. So recapping. Testing is hard because we've got all this terminology for things, but really the question that we need to be asking is how much reality do our tests need? And if we can determine that, sort of incorporating it into a testing strategy for our application that uses a few high fidelity tests and some manual testing, but the majority of our testing is lo-fi, cheap to run and automate, that verify the behavior. If you're doing TDD, that can also help shape the code design. That's a topic for a different screencast. Yeah, so that is basically, we looked at the boundaries in our application and talked about how different testing strategies are covering different pieces of those, and then this idea of low res versus high res, and some of the tools that we used. So I hope that this screencast has helped you and that you'll be able to talk with your team about some of these things. Talk, if anything, just about what test strategy we're going to use when testing our AngularJS applications. And I've given you a couple of tools. You can check out Lineman. You should definitely check out Protractor because it's going to replace the Angular scenario runner. So it's worth checking out. You can check out Lineman if you want to write rich web applications. We've got all of these testing tools baked in the Lineman Angular template, which is what I used for this screencast. So you can check that out. And I'll include links to all this stuff. So hopefully that gets you up and running with testing and covers some testing strategies with AngularJS.